Hi, welcome to Learning Monkey. I am Raghuir. In this class, we do some practice programs in Python on data structures. In our previous classes, we have given so much of intuition about how data structures are implemented, and we have done some examples. So based on that, you can easily solve all these questions. So please follow our playlist so that you will have a better understanding. The link for the playlist is provided in the description below. Coming to today's class, you can visit our website learningmonkey.in for taking placement practice tests. Coming to today's program, let's take the question, try to solve it on your own, then check for the solution. So this is our first question. Here the question is, consider the following binary search code given below. So they have given the binary search code in our data structures playlist. We clearly discussed about binary search, and the implementation is done in recursion. Here they have done the implementation using loops. So try to understand the concept of binary search, how they implemented in Python using loops, and try to solve the question. What's the question? Consider the following binary search code given below. This is the list of elements. They are sending it to the binary search function, and element is equal to 7. So how many iterations needed to search the given element? In order to search the given element in binary, this is the list of the elements. How many times this while loop has to be executed? That is what they are trying to you have to identify. So this is our first question. Okay. Coming to the second question, this is about hashing. Which of the following hash functions will lead to least number of collisions when the following elements are inserted in hash table? So you have to take the hash table. On that, these are the list of the elements you have to insert in the hash table. So which of the following keys will provide the minimum number of collisions? So which of them you have to identify, either 1, 2, 3 or 4. So which of them is providing the least number of collisions? This is our second question. Okay, coming to the solution part, let's try to understand the binary search logic as we discussed in our previous class, in our data structures classes. So how binary search works. In order to execute binary search, we need elements in ascending order. Okay, the elements are given in the ascending order. We have to identify the element 17 in the given list of elements. So what's the logic? Let's try to understand the logic first. So here we are taking low value is equal to 0, high value is equal to length of numbers list minus 1. Means low value, this is our list, this is our list. Low value is taken as 0. For the first time, low value is taken as 0. High value is taken as a 5. While low less than or equal to high, this loop is going to execute until low less than or equal to high. Low less than or equal to high means whenever low value pass the high value, this loop is going to break. That is what the condition is. Inside the condition, they are identifying the mid value low plus high by 2, and they are trying to check. See, inside the condition, they are trying to identify the mid value low plus high by 2. And the condition here is already elements are in ascending order. So what's the mid value? Low plus high by 2, 5 by 2. 5 floor division 2 means the integer value 2 will be considered. So the mid position is 2. We have to check the element 17. Is 7 equal to 17? At this position, we are identifying the mid position. At this position, 7 is equal to 17? No. But 17 is greater than 7. Elements are already in ascending order. So, compulsory, our element will be on the right hand side. No need to check these elements. That is what binary search is. So, we have to check the remaining elements on this side. So, low is equal to 3, high is equal to 5. That is what we have to do. Next, in the next iteration, low value will be mid plus 1. Mid plus 1 means third position. Up to third position to fifth position, we have to identify. Again, calculate the mid value. 3 plus 5 by 2. So mid is fourth position. So 15 equal to 17. No. 17 is greater than 15. So which side we have to check? Again, we have to check this side. So 4 plus 1. So the next time low value is equal to, so the next time low value is equal to 5, high value is equal to 5. 5 plus 5 by 2, 5. So what's the mid position? 5. 20 equal to 17? No. 20 is not equal to 17. So what's happened here? 17 is less than 20. So high has to move this side. High has to move this side. High minus 1, mid minus 1. Mid minus 1 is the high value. Now high is pointing to 4, low is pointing to 5. Elements are completed. There is no element 17 in this list. Whenever low greater than high, low greater than high, stop the execution of the loop. How many times loop executed? First time, second time, third time. 3 times loop executed. After that, low is equal to 5, high is equal to 4. Condition fails, it is not going into the loop. So the answer is 3 times. It will execute for 3 times. Okay, check the condition. So coming to the next example, we have to identify the hash table. Which of them are having the minimum number of collisions? 48, 98, 34, 25, 18. So what's the hash key? Key mod 8. Key is the 48. We have to take 8 elements. For the first one we are explaining. So we are having 8 positions, 0 to 7. Key mod 8 means 48 mod 8. What is the value? 0. At 0th position, 48 has to be placed. That is how hash function works. At 0th position. And 98 mod 8 output is 2. At second position, we have to place 98 value. 34 mod 8 2. So already 98 there. 98 is there at the second position. So it is a collision. It is a collision. So one collision obtained. 25 mod 8 1 is 1 empty? Yes, it is empty. We can place it at one position. 18 mod 8 yes, 2 again collision. So how many collisions obtained by using the key value key mod 8? 2 collisions are obtained. This one and this one. The same way apply it to for the remaining values. So modulus 10, 48 modulus 10, 8, 4, 5, 8. How many collisions? 8 is a collision. 8 is a collision. 2 collisions obtained. Again, mod 9, 3, 8, 7, 7, 0. How many collisions? 1 collision. Only 7 is the only 1 collision we obtained. So next one is mod 3 value 0, 2, 1, 1, 0. How many collisions? 0, 0, 1 collision. 1, 1. This one 1 collision, this 0, another collision, 2 collisions. Which one is having the minimum number of collisions? Number 9 is having the minimum number of collisions. This is how hash functions are. Hash table will execute, how it will identify the hash collisions. Hope you understand the concepts. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates.